Hey everybody, this is Miss Berry. In this video, we're going to go over section 9.3, which is called Saving Money. All right, so let's start off by looking at our first formula. All the formulas in this section are pretty complicated, so you want to copy them down carefully. You may want to take a second and pause the video and make sure you have them all written down correctly. So this formula is for the present value of some account. While you're writing that down, I'm going to just talk a little bit about these formulas. So we learned in the last section about interest. Sometimes, you may think of interest in a negative way because, you think of like you pay interest on a credit card, you pay interest on your car loan. But interest isn't always a bad thing, and it can be a huge help when you're saving money. If you are investing in some kind of savings account, it's good to explore your options for what type of interest rate different banks are offering for different types of savings accounts. So suppose that we have some particular monetary goal that we would like to save for. Maybe we want to save $5,000 to put a down payment on a car. We can take and rearrange the interest formula that we learned in the last section and get out this formula here, which is for the present value. So this is going to tell us the amount of money that we need to invest right now in order to reach some future value amount. A is the future value amount. That's the amount, say, that we want to save for our car loan. R is your APR, your interest rate. N is the number of compounding intervals per year. And T is the time or term in years. So let's look at our example. It says use the formula for present value of money to calculate the amount you need to invest now in one lump sum in order to have $25,000 after 10 years with an APR of 6% compounded quarterly. Round to the nearest cent. Right, so I'm going to write down the formula for present. So present value equals our goal amount A, which was $25,000, over 1 plus R over N raised to the NT. How I like to do this, just so like whenever I look back at this later, I know exactly what I plugged in. I like to write off to the side what I'm replacing these letters with. A is our goal amount. We want to save $25,000. It's told us our APR, our interest rate, was 6%, which as a decimal would be 0.06. And it told us that this is compounded quarterly, so that's our value for N. Quarterly means 4 times per year. And then our term of our investment was 10 years. All right, so you have some kind of savings account. They're giving you a 6% interest rate, which is a great interest rate for a savings account. We want to get to $25,000. They're compounding this quarterly at this bank, and we're going to leave the money in there for 10 years. All right, so let's plug this in. I'm going to write this in a different color. So we have present value equals 25,000 over, well, try that again. 1 plus R over N, so 0.06 over 4, raised to the N times T. So that's 4 times 10, which is 40. I like to go ahead and just simplify the exponent. That's my preference. I'm going to adjust some things here so we can see the calculator at the same time. All right, so let's plug this in. I'm going to hit my little fraction button. If you're using the TI-36 like me, it's right down here. It's right above the 7. You can see right there. All right, so 25,000 over parentheses 1 plus 0.06 over 4, close parentheses, raised to 4 times 10, which was 40. And there we go. That's the amount we need to save right now. Or excuse me, that's the amount that we need to invest right now in order to have $25,000 in 10 years. So we're rounding this to the nearest cent, which means 2 decimal places. So this is going to be 13,781 and 56 cents. So the present value, the amount we need to invest right now, is 13,781 and 56 cents. And in 10 years, we just leave that money alone. We don't mess with it. In 10 years, that'll have grown to $25,000 with these specifications, which again were that the interest rate was 6%. They were going to compound our interest quarterly, and we were going to leave the money in there for 10 years. All right. So let's look at our next example. It says Draper College predicts that in 16 years, it'll take $300,000 to attend the college for 4 years. So $300,000 sounds like a lot of money. Let's see, that's $75,000 a year. So that would be along the lines of a college like Vanderbilt. It says Emma has a substantial amount of cash and she wishes to invest a lump sum of her money for her child's college fund. How much should Emma put aside in an account with an APR or annual percentage rate of 12% compounded monthly in order to have $300,000 in the account in 16 years? Okay, so she's predicting that it's going to cost her daughter, or no, I'm sorry, not her daughter, for her child. So she's predicting it's going to cost about $300,000 for her child to attend college. And she has some money that she wants to put aside. So that's going to be the present value formula because we have some kind of goal in mind. We want to reach $300,000. So I'm just writing down the present value formula. A over 1 plus R over N raised to the NT. All right, so let's write down what we're plugging in. A is 25,000. Excuse me, not 25,000. That was the last problem. It's 300,000. That's our goal amount. Our APR, our interest rate, was 12%, which as a decimal would be 0.12. This is compounded monthly. So N is the number of compounding periods per year. So that would be 12 if it's compounded monthly. And she's going to leave the money in the account for 16 years. All right, so let's plug everything in. You have present value equals 300,000 over 1 plus R over N, so 0.12 over 12 raised to the N times T. So let's see what that is. 12 times 16 is 192. All right. If you're using a graphing calculator, let me show you how you would type this in. Let's say you don't have a little fancy fraction button and you want to type this in. You would do 300,000 divided by, and in parentheses, 1 plus 0.12 over 12, close parentheses, raised to the 192. All right. So that's how much Emma needs to invest today to have $300,000 in 16 years. So we're rounding to 2 decimal places. That would be $44,403.53. And 53 cents. So in 16 years, that'll have grown to $300,000, which is pretty cool. So I know this may seem unrealistic to you, but you can imagine this might be like Maybe you receive some kind of inheritance money. You could invest it. And then 16 years later, instead of having $44,000, you have $300,000. Okay, so let's look at a different type of problem now that we've done a couple of those examples. All right, so we're going to talk a little bit about annuities. You've probably heard the word annuity before, like on those J.G. Wentworth commercials. An annuity is a sequence of regular payments that are made into an account or taken out of an account over time. Those type of annuities that people are referring to might be like an insurance payout, and they have, the money separated like into months, like you receive a check every month. But in our class, when we refer to an annuity, this is going to be where we have some sort of savings program where instead of investing some kind of lump sum, we're going to make a series of regular payments into an account over a certain amount of time. So compound interest, again, here is going to work in our favor because even though say we put $50 a month into this annuity or into this savings program. So the first month, we're only earning interest on $50. But after we make 2 payments, then we're earning interest on $100. Then the next month, we're earning interest on $150. Then the next month, we're earning interest on $200. So, it doesn't take a big lump sum investment to save a generous amount of money. And that's what this formula is going to show us. So the annuity formula for finding the future value is where we're going to find the future value of some kind of annuity payment plan. So it not only is taking into account the compound interest that you are earning, it's also taking into account that you're making these regular payments. So that's what that PMT stands for, is payment. So it says the future value FV of an annuity savings account is calculated with the formula FV equals payment times, in the numerator we have 1 plus R over N raised to the NT minus 1 all over R over N, where PMT is the payment amount that you're depositing on a regular basis, R is the APR, the annual percentage rate, N is the number of regular payments that you're making each year, and FV is the future value after T years. So let's look at an example. All right, so Rachel starts an IRA, which is an individual retirement account, at the age of 26 to save for retirement. So if you work at a job and your job has a retirement account, a private retirement, then you may not need to worry about an IRA. But if you work somewhere, like say at a hospital, most hospitals do not have IRAs, they do not have like private retirement accounts. So you may have to start an IRA whenever you start your job. And, you don't have to invest a lot of money into an IRA to have enough saved whenever you retire to live comfortably. The important part about starting an IRA is to start early. So you want to start early in your career. You don't want to wait around until you've been working for 10 or 15 years to start a retirement. You want to start it as soon as you start working, or even before you start working. You could go ahead and open an IRA. So you can see in this example, Rachel's starting an IRA and she's 26 years old to save for retirement. She's depositing $350 each month, not a huge amount. It says the IRA has an annual interest rate of 7% compounded monthly. How much money will she have saved when she retires at the age of 65? Round your answer to the nearest cent. All right, so first of all, let's think about how long she's worked. So if she retires when she's 65 and she started saving when she was 26, let's see. Wish that would just go back to where I had it. All right, so 65, when she retires, she started saving when she was 26. So she has saved for 39 years when she retires. Let's see if my light's on. Yeah, it was. Okay, I think the light's better. Okay, so she has been saving for 39 years whenever she retires. So we're trying to figure out if she makes these regular payments of $350 a month into her IRA, how much is she going to have saved in the future after she's worked for 39 years? So we're going to use our future value formula, which is very complicated, so we want to be careful writing it down. We have payment times, then we have that big fraction. In the top, we had big bracket, parentheses, 1 plus R over N raised to the NT, minus 1, close bracket. And in the bottom, we had just R over N. All right, so we're going to take our time plugging this in. I'll do one example where I plug it in on the TI-36, and then I'll do one example where I plug it in on the graphing calculator. All right, so if you want to, we can still go ahead and write out. Oh, go ahead. We can go ahead and write off to the side what all we're plugging in. I think that's a great idea. Like I said, that way when you look back at this later, you know exactly what you plugged in. The payment that she's making each month is $350. Her interest rate was 7%, so R is 0.07. Our compounding periods, this is compounded monthly, so that's going to be 12. And T was the number of years that she's invested in this money, so that was 39 years. That was how many years she's worked or how many years that she saved for before she retired. So this is going to tell us how much money Rachel's going to have when she goes to retire. All right, so here we go. Press your little, well, first we need to type in the payment, right? So forgot I was supposed to write this out. Getting excited. I want to find out how much money she's going to have saved. All right, so 350 times. In the top, we have 1 plus 0.07 over N, which was 12, raised to the NT. All right, 12 times 39 is 468. It's a lot of compounding periods. Minus 1. That means her interest got compounded 468 times. Divided by R over N, so that's 0.07 over 12. Okay. All right, clear that out. Now let's start typing this in. Don't forget 350 in the front. 350 times. And I'm going to hit our little fraction button down here. Down here. All right. I'm going to put a big parentheses in the top. You really don't need to if you're doing the fraction button, so you don't have to worry about that. So 1 plus 0.07 over 12, close parentheses, raised to the 468th power. Get out of the exponent. Minus, whoops, hit a plus, minus 1. All right, and then the denominator, we have parentheses 0.07 over 12. You really don't have to put that in parentheses, but I went ahead and put it in there since it was in the formula. When you have this little fancy fraction button, you don't have to worry about putting parentheses around the denominator. And there we go. That's how much Rachel's going to have saved after 39 years. She's going to have $852,705.16. And that's all from just depositing $350 a month in this IRA. All right. And then you can think about, like, if you say if you retire and you have your house paid off and you have your car paid off, all that kind of stuff, you're really set up pretty nicely at your retirement if you don't have very many bills. All right. Let's look at another example. And again, I'm going to do this one with the graphing calculator just in case anyone's using this one so you know how to type it in. Whoops. Clear that out. Okay. All right, so this one says a very similar problem. It says Connor starts an IRA at the age of 26 to save for his retirement. He deposits $350 each month. Upon retirement at the age of 65, his retirement savings is $734,088.65. Determine the amount of money Connor deposited over the length of his investment and how much he made in interest upon retirement. So this one sounds complicated, but it's actually going to be pretty easy, I think. So let's see. How much is he? Okay, first part says, determine the amount of money he deposited over the length of his investment. All right, so how much, whoops, let me use a different color. How much did he deposit over the length of his investment? That was the first question. So let's see. Told us he was depositing $350 each month. And it says he started when he was 26 and he retired when he was 65. All right, so he worked until he was 65 and he started saving when he was 26. So that's the same numbers as before. 65 minus 26 is 39. That means he saved for 39 years. So he saved $350 each month. So that's 12 times a year for 39 years. So 350 times 12 times 39. 350 times 12 times 39. So that means, whoops, I deleted something. Okay. So over the length of his investment, he deposited a total amount of $163,800. All right, so that's the answer to the first part. And then, how much interest did he make upon retirement? All right, so how much interest did he make? All right, so it told us that this was the amount that he had in his savings when he retired. So we'll just do the total amount in his account and then subtract off the amount that he invested, which was $163,800. All right, so $734,088.65 minus $163,800. All right, so this is how much interest that he earned. So this is money. So that was $570,288.65. He made a ton of money in interest. Let me go back and just show you. I just want to make it clear for the folks that have a different type of calculator how you would plug in that formula from number 3. So if you feel comfortable plugging in, you can skip this part of the video. But if you would like to see me plug this in on the graphing calculator, that's what I'm going to do now. I'm just plugging in from right here. Let me see if I can get my pen to show up. Okay, here we are. I'm plugging in right here. 350 times. I have to put big parentheses around the top here. So parentheses 1 plus 0.07 over 12. Whoops, 12. Raised to the 468th power minus 1, close big parentheses, divided by parentheses 0.07 over 12. And there you go, same answer. So I just wanted to show you how to plug it in if you don't have that little fancy fraction button. All right, let's see how we're doing. I want to say this is our last formula. Yeah. So this is going to be where we are trying to work towards a goal. So this is where you have some kind of goal in mind. It says that, suppose that maybe you're living in a house and it's kind of a small house. Sorry for the email notification. But maybe you're living in like a smaller house and your goal is to live in a bigger house and you want to save like $30,000 for a down payment on this bigger house. Then if you are trying to reach a future goal with an annuity savings account or annuity savings program, this is the formula you'll use. It says the regular payment amount, PMT, which is needed to reach a future goal with an annuity savings account is calculated with this formula. Payment equals your future value, that's your goal amount, times R over N divided by, big brackets, 1 plus R over N raised to the NT minus 1. You can see that this piece right here looks familiar. It's from the last formula, except it's just the reciprocal, so it's flipped. All right, so let's look at an example. It says, Sophia and Manuel are purchasing a home. They wish to save money for 12 years, and they want to purchase a house that has a value of $180,000, and they want to purchase it with cash. If they deposit money into an account that's paying 5% interest compounded monthly, how much do they need to deposit each month in order to make that purchase? All right, so we're going to use that annuity formula because they're going to be making monthly payments into this savings program. All right, so we're going to write down our formula. PMT payment equals future value, that future goal amount, times R over N divided by, big bracket, 1 plus R over N raised to the NT minus 1. In our example, the future value, their goal amount is $180,000. Their interest rate, R, is 5%, so 0.05. This is compounded monthly, so that's 12. N is 12. And they're going to save, they said, for 12 years. So that was up here at the top. All right, so let's write down what we're going to plug in. Payment equals 180,000 times R over N, so that's 0.05 over N was 12 divided by, big bracket or big parentheses, 1 plus 0.05 over 12 raised to the NT. So that's 12 times 12. We know that one's 144. 12 times 12 is 144 minus 1. Okay, that looks better. Now let's plug this in, clear all that out. All right, so we have 180,000 times fraction button 0.05 over 12 divided by parentheses 1 plus 0.05. Sorry, it's kind of hard to see. That's a little better. Over 12. It's really annoying me that you can't read that. Okay. Close parentheses. Raised to the 144th power. Get out of the exponent. Minus 1. Oh, look, I put a plus instead of a times. I'm like, okay, that's not right. Let me go ahead and fix that. All I did, if you saw what I did, I just scrolled up to the last thing I typed in. Now I can scroll over. I need to change that to a times, not a plus. There we go. They need to deposit $914.80. Not too bad to save $180,000 in 12 years. $914.80 they need to save every month. And that's a pretty reasonable interest rate, 5% interest. So if you're wanting to pay cash for a house, you can do something like that. Save money for a certain number of years to get to your goal amount. All right, last one, I think. Maybe there's one more. Let's see. Yeah, we have two more. All right, so Rachel wishes, sorry, there was more than one Rachel in these examples. Rachel wishes to retire at age 65 with $1,200,000 in her retirement account. When she turns 28, she decides to begin depositing money into an account with an APR of 9% compounded monthly. What is the monthly deposit that Rachel must make in order to reach her goal? All right, so she's doing an annuity savings program. She's going to deposit money each month. She has a goal amount of $1.2 million. And let's see how long she's saving for. She wants to retire when she's 65. She starts saving when she's 28. So clearing all that out, 65 minus 28, she's going to save for 37 years. All right, so let's write our formula. Payment equals future value times R over N divided by, big bracket, parentheses, 1 plus R over N times, raised to the NT minus 1. All right, let's write down what we're plugging in. She wants to save $1,200,000. Or that's how much she wants to have in the account when she retires. Her interest rate is 9%. That's a pretty big interest rate. N is the number of compounding periods a year. She's compounding monthly here. And we said she was going to save for 37 years. All right, so let's plug all these numbers in. So we have payment equals $1,200,000 times R over N, so that's 0.09 over 12, divided by 1 plus 0.09 over 12, raised to the N times T. So N times T, that's 12 times 37, which is 444. That's how many times her interest is going to get compounded. And minus 1. All right, let's plug this in. I'll plug it in on the graphing calculator this time. So you can have an example of each. All right, so we have 1,200,000 times. Now we're not doing the fancy fraction button, so we got to put the top and the bottom in parentheses. So it's 0.09 over 12, close parentheses, divided by big open parentheses again, 1 plus 0.09 over 12, close parentheses, raised to the 444, get out of the exponent, minus 1, close parentheses. All right, so Rachel needs to save $338.43 a month. Let's write a dollar sign. $338.43. Now, this is much less than the last example because even though we're trying to save more money, because she's investing for a much longer period of time, she's investing this money for 37 years. And she has a much higher interest rate. So in the last one, I think it was 5%, and here it's 9%. So she's making a lot more interest off of her investment each month. All right, we have one more. I wanted just to show you this one because it's not as difficult as it seems. It says Cyrus deposits $1,191.48 each quarter into an annuity account for his child's college fund in order to accumulate a future value of $85,000 in 14 years. How much of the $85,000 will Cyrus ultimately deposit into the account, and how much interest did he earn? All right, so let's figure out how much he's depositing into the account over time. He's putting in $1,191.48 each quarter, so that means 4 times a year for 14 years. All right, so 1191.48 times 4 times 14. All right, so he's depositing $66,722.88. And then how much interest did he earn? There was $85,000 in it whenever he, at the end of his investment period. So subtract off the amount that he invested, which was that $66,000. So $85,000 minus $66,722.88. So this is how much interest he earned. $18,277.12. So what this indicates to me is that Cyrus had a pretty low interest rate on his investment, which is why he had to actually put up most of the money, and he was only earning $18,000 interest. Sorry about that. All right, so that is everything for this section. You have to practice to get good at plugging these in the calculator. They take lots of work. It seems like it's easy right now because I've plugged these in. I could do this, I've done these a lot, so I have lots of practice plugging these in. But you're going to have to take time and work on these and practice plugging them in to get good at it. But if you have any questions, you can always email me and let me know. Otherwise, I'll talk to you guys soon.